will yield to the realities of life. Yeah. Oh, let me also. Oh, and also. Please take your seats. Guys, if it's possible for those who are sitting in the outer edges to move in. I know it's nice to sit at the edge. I always love to sit at the edge. But there's then lots of empty spots in the middle, and people can come in. There's nowhere for them to sit. And they don't want to trample over your feet to get to the seat. So they go away. That's a terrible outcome. Okay. Yes? Start. All right. Hello, everyone. We're extremely lucky to have Professor Christopher Rapley with us from University College London. He's a climate scientist and with a very impressive background, and I'll tell you a little bit about his background. But he will be talking about climate change and finding the agency to act. So it's almost like the problem of everyone knows smoking is bad for you, but they don't stop smoking. It's almost like everyone knows climate change is happening and we're not doing something about it. So it's knowledge, this is the gap between knowledge and behavioral change, right? So he will be touching on this issue and the political and behavioral change at a systems level, which is much more complicated, right, than individual behavioral change. Or maybe it is, I don't know. Okay, so Professor Rapley will talk, but I have to tell you, there will be a Q&A period afterwards, 15, 20 minutes, however long you need to ask questions. And then we will move into some of our undergraduate students will be invited to stage. And these are students who've done some climate-related work, and they're familiar with the topics, issues. And they will ask very sharp questions from what we call decision makers. We didn't invite government here because it would have been a different show if we did. So, but we did invite experts who have worked in decision-making capacity or doing work that will, impact decisions in the country, and they will be challenged to answer students' questions, right? So we'll get to that in due course. So Professor Rapley is a professor of climate science at University College London. He's a fellow of St. Edmund's College, Cambridge, a distinguished visiting scientist at NASA's JPL. We had, Negin Cox yesterday from JPL, a member of the Academia Europaea, a board member of the Winston Churchill Memorial Trust, a chairman of the European Space Agency Director General's High-Level Science Policy Committee, and chairman of the London Climate Change Partnership. He's also ran a lot of institutions and research efforts in the UK, but also globally. Director of the Science Museum of London, British Antarctic Survey, director of that initiative, executive director of the International Biosphere program at the Royal Swedish Academy of Sciences in Stockholm. And if Professor Markides, our president, was here, I'm sure you would find a million contacts with each other amongst you. And now he's heading the Earth Observation Satellite Group at University College London's Muller Space Science Laboratory. His current interests are particularly on climate science and communication of climate science, which is one of the big challenges. And I will let him talk more about the play that he wrote with Duncan Macmillan. All right, Professor Rapley, we're very happy you're here with us.
Thanks very much, Alan. Thank you. Cheers. Thank you so much, Alan. Thank you for the introduction. It's a real pleasure to be here. It's my first time in Armenia. I've only been here a few days, but I feel I've had such a warm welcome. I feel that I've been here a long time. And I'm very excited for you all because not only the tour of the university that I had this morning, but also what I've seen of the country and, of course, the Starmus Festival really give a strong impression of a country that is heading somewhere progressive and exciting in its future. And you're the people who are going to be participating in that. So I envy you that. I think it's going to be a very exciting time for you all. So I started my career in university. I trained as a physicist. But in fact, I was lucky. And in the days when it wasn't really normal to be able to mix and match courses, I managed to do an astronomy course. At my school, I hadn't done any astronomy. And that completely inspired me. And it was a turning point in my career. And so quite quickly, I found myself in a space science lab, whereas as an experimental physicist, I was building and designing instruments to fly on rockets and satellites to get above the atmosphere and open up new windows on the universe. So every time we managed to get an instrument above the atmosphere, we knew we would discover something new. It was a really pioneering age. So that was really thrilling. And then after a bit, I realized that if you turn those satellites over, you could look down at the Earth and see the Earth in a different way. We use the word microscope to describe an instrument that allows us, big things, to study something very small. And so in those early days of remote sensing, satellite remote sensing, we tried to get people to adopt the word macroscope because the satellites were allowing us, very small creatures on the planet, to see the planet in its immense complexity, but as a unified object. All of the parts of it, the atmosphere, the ocean, the ice, and so on. So that was my background, and for many years I was more comfortable holding a soldering iron and operating equipment and watching rockets go off than doing other things. And unfortunately, in some ways, my career has long gone. I haven't held a soldering iron for ages. And so if we fast forward to this moment, I find myself standing in front of you in a very strange role, one I would never have imagined at the time that I would find myself in. But I'm here as a storyteller. And the story that I'm telling is an epic one. It's an epic drama, arguably the most epic drama that humans have ever encountered. And what's interesting is that you and I and everybody else on the planet are the cast, and we're also the script writers. And of course, that story is the story of the climate crisis, and more generally, the environmental crisis, the biodiversity crisis. But I'm going to focus on the climate crisis. And so that's what I want to tell you about today. And as Alan pointed out, knowledge, information, understanding is all very wonderful. It's very satisfying for us to generate it. But unless that knowledge, understanding lands successfully in society, and society responds, then arguably it's not really very useful. And so what this talk is about is climate change. We'll talk a little bit about the problem of climate change, but really I want to reframe the story as climate change as an activity. And so that's why I've used this word agency. Agency is the ability to do something, the ability to affect the world around you in the future. And so with climate change, how do we find the agency to act? So you don't just have to, it's not just human beings that can tell stories. Some of you may have read in the newspapers over the last few weeks that many of the rivers in Europe are at all-time lows. And they're exposing rocks. And some of those rocks are telling stories, and they're called hunger stones. So these rocks on the Elbe in the Czech Republic have been exposed, and they're telling a story which dates back as long as 500 years. So the first inscriptions are 500 years ago. And the inscription reads, "If you can see me, weep." Because the whole point is that when you have a drought so severe that the water level is that low, then you almost certainly have famine, and people suffer. So these stones are telling us there's something unusual and something rather dreadful going on. But it's not just on the Elbe. This is an image of the Rhine. The Rhine is an essential waterway that transports goods throughout Europe. And yet that transport is being disrupted because the Rhine is currently so shallow that the barges can't navigate it. This is the Danube in Budapest. This is a tributary of the Loire in France. This is a lake in California. This is the Parana, the longest river in South America. This is an area in Asia, in India. This is in China, and then this is also in China. So it has happened in the past that severe droughts have occurred in certain regions, but it's extremely unusual that you should have this synchronized drought occurring right the way around the world. And if we look at what's going on, this is from a month ago. This is the meteorological map of Europe showing all of these extreme temperatures, and the dark areas are incredibly hot. And at pretty much the same time, you have this enormous heat wave across China and Asia. And if you back away, this is satellite data, you can see that around the world you have this band of extreme heat. And of course, human beings really suffer. If you get a wet bulb temperature greater than about 35 degrees, then the human body literally cannot stand that exposure for more than an hour. You suffer from organ failure and so on. So this is an extremely unusual coincidence and an extremely serious one for human beings. And what's interesting is that whereas climate change was something of a taboo subject in the general media 10 years ago, even 5 years ago, it's now become a drumbeat. These messages from the planet are being transmitted to us on a daily basis through the media. In this case, I've just picked some headlines from last week. This was last Thursday. I checked my phone this morning, and there are more signals, heat waves elsewhere. You know, it's happening all the time. So there's this chorus, this drumbeat of messages from the planet in a way that hasn't happened before. So pretty much anybody who reads a newspaper, looks at social media, or listens to the news is aware that something pretty serious is going on. At the same time, we see headlines like these. In Pakistan, at this moment, a third of the country is flooded. 30 million people are affected, some very seriously. 1,000 people died at the beginning of the floods. And it's not just in Pakistan. This is Mississippi, so the floods are happening as well. And you ask yourself, well, wait a minute, how can that happen? You've got drought, and at the same time, you've got extreme flooding. So what's going on here? Well, this is where physics is helpful. And this is a little bit of 19th century physics that says if you warm air, it's capable of carrying more moisture. So for every degree centigrade you warm the air, it can carry 7% more moisture. And that does two things. It means that the air is more effective, more efficient at drawing moisture out of the ground and out of the vegetation. So it makes the ground and the vegetation drier, causes those droughts, the rivers become very low. But that moisture now is being carried by the atmosphere in warm air, and when that warm air either lifts to where the temperature is reduced or where it meets cold air, it precipitates that water, it condenses in much more intense bursts than it would normally. And so you get these flash floods. And then the situation is made worse because those flash floods land on land that is baked and dry, which they can't soak into, and so you get flash floods that carry across the land and cause all of the damage. So a little bit of physics explains why we can have these two sets of headlines that at first sight seem to be contradictory. They're not. It's just part of the way the world works. So that's what we hear on a daily basis through the news. What has the science community got to say about this? Well, the climate science community has been, first of all, Fourier in 1850, whatever it was, 1830, understood that if you warmed the atmosphere, if you added greenhouse gases to the atmosphere, it would warm the world. So the science has been kind of understood for a long time. The Swedish chemist Arrhenius in 1890 did some laborious hand calculations to figure out how much the world would warm if you doubled the amount of CO2, and he came out with a value of about 4 or 5 degrees, which is pretty good. It's not bad. So we've known about this for a long time, but it's been a kind of intellectual oddity. It's not really landed anywhere in society. But there was a realization building up from about the 50s, 60s onwards that this was a significantly serious problem that the academic world should really engage with it. So the physicists, the meteorologists, the biologists, the chemists, and so on, a huge army, if you like, of scientists around the world, literally hundreds of thousands of very bright people working away at different parts of this problem, have been publishing more and more and more journal publications on how the climate system functions, how this complex interacting system functions as a whole. And in 1988, the United Nations recognized that climate change was a sufficient problem that they would marshal the academic community to synthesize the knowledge that's being generated out there into messages that could be delivered to governments and decision makers so that they could take action. So the IPCC has been working away at this, the Intergovernmental Panel on Climate Change, since 1988, and they've been producing a report every 5 years or so. And about this time last year, Working Group 1 produced its 6th report. And the headline, if you like, is here. It said, "It is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred." And remember that there's been a long, long argument with lots of people saying, we don't believe you, climate has changed in the past, so what? Well, of course, we didn't occupy the planet with the modern world built for the climate system we inherited, not the one we're provoking. So there have been all sorts of argument and uncertainty. This is a really solid statement. This is the climate change community saying, there is no doubt, if you don't want to believe us, fine, but there is no doubt we've got a serious problem. So that's Working Group 1 that looks at the science of how the system works. And then Working Group 2, which looks at, Working Group 3, which looks at how you can mitigate against this, came out a few months later with this statement and said, it's now or never. If we want to limit global warming to 1.5 degrees, which is the agreement that was made in Paris in 2015, without immediate and deep emissions reductions across all sectors, it will be impossible. In other words, they're saying it's no longer just the social inertia that is limiting what we can achieve, but actually the basic laws of physics, chemistry, and biology say that if we don't do something now, then we're not going to meet 1.5 degrees, and we may not meet 2. So this is a pretty serious message, and the Antonio Guterres, the Secretary General of the United Nations, said, and in a world in which slogans seem to have more impact than real evidence, he captured it by saying, this is code red for humanity. Listen to us, code red. So what's going on here? Well, as a physicist, I like to try and understand, what's the deep cause of all of this? And at the most basic level, what we have done is we have upset the energy balance of the planet. If you think of it, the planet is intercepting heat and light from the sun. That heat is used to drive the motions of the atmosphere and the ocean, the fluids. There's a temperature difference between the equator and the pole, so that drives these motions. And on a rotating planet, they're quite complicated, with topography as well. So that's all tricky, but it can be understood. It also, that light in particular drives the biosphere, so everything, all of life requires, the green stuff is the base of the food chain for everybody. But anyway, it drives the motions, and then that degraded heat is radiated out into space. And so over the long history of the planet, the 4 billion year history of the planet, the balance of the incoming energy and the outgoing energy has been equal to many, many decimal places. If it isn't equal, the planet either cools down until it finds a new equilibrium, or it warms up until it finds a new equilibrium. And what we have done, and you all know the story, by injecting into the atmosphere more and more greenhouse gases, particularly carbon dioxide, we have upset that energy balance. And so as we speak, the planet is accumulating energy at the rate that would be equivalent to every person on the planet, all 7.8 billion of us, having 40 1.5 kilowatt electric kettles continuously pouring hot water into the ocean. And that's quite a good analogy, because 94% of the energy goes into the ocean. Only 2% goes into the land, 2% into the atmosphere, 2% into the ice, roughly. Well, we don't live in the ocean, and so we're not aware of all of that energy accumulating in the ocean. We don't feel it. The biology, the inhabitants of the ocean feel it, the corals, the marine biosphere feels it, but we don't know about that. We just feel what's happening in the atmosphere and on the land. Again, to put it into context, that energy imbalance is 20 times the energy that humanity generates each day to run the modern world. Everything, all the energy that we use to do everything, industry, travel, home, domestic, 20 times that. And so that unintended consequence is massive, absolutely massive. And you don't need to be a rocket scientist to say, hey, I'm playing with this complicated system to make it do something that I want to happen. But unfortunately, the downside is an impact on it which is 20 times greater than the thing I'm doing for my benefit. It's not very smart. So this image is quite useful. It's a very old image, actually. It's from a meteor satellite, geostationary satellite from decades ago. But it's not the one that you normally see of this beautiful blue orb sitting in the blackness of space. It looks at first sight a little bit more boring. It's actually a thermal infrared image, and it's sort of inverted. The dark areas are warmer than the light areas. So the light areas are high altitude clouds, and the dark areas are, quote, the clear atmosphere. Except if you look at the dark areas, you cannot see the surface. If you would, you could see the coastline of Africa and so on, because that's where the satellite is looking. And so this is a direct demonstration of the greenhouse effect. The heat that is coming off the land, off the surface, the ocean and the land, is struggling to get to the point in the atmosphere where the remaining gas is thin enough that it can escape to space. And it gets up there, it gets up to that level both by convection and by multiple radiation. And so by adding more carbon dioxide, we have made it more difficult for that heat to escape, and that is why we've got this energy imbalance. And the planet is desperately trying to warm up to compensate so that it can push more of that energy out. But we keep beating it. It's a moving target. We keep adding more and more CO2, and so the planet is constantly trying to chase that equilibrium, and it can't get to it. So it's a nice demonstration of what you hear about all the time, the greenhouse effect, but here it's visualized. So here's something else. I was director of British Antarctic Survey for 10 years. One of the things that the ice sheets in Antarctica and also Greenland offer us is a picture of what happened in the past. If you drill down through the ice, you go back in time. The ice accumulates yearly, with a small amount of snowfall. And so if you drill backwards, you go down in time. And in Antarctica, the ice is up to 4 kilometers thick. 4 kilometers is a long way. And it goes back about 800,000 years in time. And what's happened is when that ice is formed and compressed, it traps bubbles of air. And you can see them in this slice through an ice core. You can see all these little bubbles. And so these are samples of the atmosphere that run continuously from present all the way back 800,000 years. That's as far as we've got. As we speak, they're trying to drill a core which will go back 1 million years, or maybe 1.5 million years, which will be very exciting. So here's this is an ice core. You can see the bands in it. And here's the trace going back from the present into the past, 800,000 years. This is carbon dioxide. Here's the measure. And you see these, this sawtooth oscillation. And these are the ice ages. This is 8 ice age cycles, 110,000 years each. And you can see it if you start at the beginning, you go up into a warm period, an interglacial. You gradually crank back down into an ice age, and then something happens and you pop out again. And we understand what's driving this. It's all to do with the Earth's orbit and the tilt of the Earth. I won't go into that. So there's the time scale. What matters, the message I'm trying to deliver here, is that you can see that throughout this period, the natural sort of pulsing of the planet from cold to warm, on which the carbon dioxide trace fits perfectly. If I put the temperature trace, they would just overlay each other, methane as well, as it turns out. That during that period, the upper limit has been about 280 units, and the lower limit has been about 180 units. So that's the natural variation. The Earth manages itself in such a way that it doesn't, in this recent period, exceed that upper value or go further down than that lower value. So there's about 100 parts per million difference between the two, when the planet globally changes about 5 degrees. I was born in Birmingham in the middle of the UK. If I had been born 20,000 years ago, it would have been difficult because there would have been a kilometre of ice over Birmingham. Anybody who knows Birmingham, a lot of people think that Birmingham would have been much better with a kilometre of ice over it, but never mind, that's a whole other discussion. Anyway, where are we now? Well, I checked the website last week, and we're at 416 parts per million. Remember that the upper limit before was about 280. Pre-industrial, it was 280. So we have gone further in 100 years of frantically burning fossil fuels than the planet has naturally in these ice age cycles. And so and this is a shock to the system. It's been done at least 100 times faster than anything that the world has experienced through natural behavior. And so the system is still responding to this. And yet we're seeing already the rise of temperature, the inevitable rise of temperature because of the energy imbalance that this induces. I'd better press on. So let's go through this quickly. As the energy accumulates, the world warms, ice and snow melt, sea levels rise because the ocean warms. It's collecting so much of the energy, so it expands, but also because of the ice on land that drains into it, adds more water. Because you've changed the temperature difference between the equator and the poles, the fluids, so the motion of the fluids, ocean and atmosphere changes. We've talked about the water cycle accelerating 7% for every degree centigrade. Extreme weather events increase, ecosystems respond, food and water supplies are affected. We see that with the droughts and the floods. Infrastructure is damaged or requires upgrading because it was designed for the climate system we inherited, which had been very stable, not the one we're provoking. People and species are impacted, and economic and political stability are affected. Now, I've explained that as if it was a linear cascade, but it's not. This is a hugely complex interacting system with all sorts of feedbacks. It functions in an often counterintuitive way. So it's not a simple cascade. All sorts of things are going on, which means that we require computer models to try, as tools to try and understand what the implications of this will be and how the future will pan out. But it's very hard to do. And so there are consequences. So I won't go in detail around these, but melting ice, Greenland, release of methane from tundra, intensified hurricanes that hit coastlines and do this sort of damage. You'll often hear people say, oh, we'll adapt to it. Well, tell the people in this place to adapt to what they experience. Flooding, fires, coastal erosion, buckling infrastructure, nuclear power stations shut down because the cooling water is too warm, migration. I just want to pick on the one of the utility pole that's on fire. Who would have predicted, I don't know any climate scientist 5 years ago who had predicted that the energy supplier to California, the richest state of the richest country on the world, would be bankrupt. And PG&E, Pacific Gas and Electric, are bankrupt because there is a $13.5 billion action against them, which they have to service, because their faulty equipment ignited a couple of the worst Californian wildfires, which destroyed 80,000 properties and businesses, and many people died as well. So the class action against them for compensation has bankrupted them. Nobody predicted that. So these consequences are playing out, rippling through the system, not just the physical system, but the social system, in ways that we didn't predict and didn't imagine. However, in general, the direction, the vector, was understood. And so this is a quote from a report by the American military from 8 years ago that says rising global temperatures, changing precipitation patterns, climbing sea levels, more extreme weather events will intensify the challenges of global instability, hunger, poverty, and conflict. Now, the only thing that's changed in 8 years is the tense of the verb. So they said it will. What we see around us, and you've seen it from my imagery, is that it's happening. What are we going to do about it? Well, we know that we need to leave 90% of all known coal reserves, 60% of oil reserves, 60% of gas reserves in the ground. If we burn those, we will completely violate those 1.5 and 2 degree limits. We must not burn this stuff. And so you hear a lot about net zero, you know, that by some magical means in 2050 we will manage to suck the carbon dioxide out of the air that we're releasing by other means. My view is that we should abolish fossil fuels. The abolitionists didn't say at the end of the 18th century, well, do you know what, we'll reduce slavery by 50% by 1810, and by 1830, any residual slavery we'll compensate for by praying or something. They said it's a dreadful thing, we're going to abolish it. We need to look at fossil fuels as something that we need to abolish. Once we have that mindset, we can all have an adult conversation about how to achieve it. It's not easy. And so where are we heading? Well, this thermometer shows the warming of the world. And remember that in Paris, it was agreed that we would aim to be in the band 1.5 degrees to 2 degrees and as close to 1.5 degrees as possible. This is where we started, pre-industrial. This is where we are now, 1.2 degrees. And the best estimates, you show a number of analyses here that look at the promises, the policies, the aspirations. But the best estimate of where we're heading is at about 2.4 degrees. And of course, that's the best estimate. There's a small probability it could be much higher than that. There's a small probability we could be lucky and it could be much lower than that. But given that what we're seeing with 1.2 degrees in a nonlinear system, I would really prefer that we didn't get to 2.4 degrees by the end of the century. It's going to be a very rough ride if we do. So why is it that we're having problems? Well, we have all of this equipment, satellites, things in the ocean, all of these scientists beavering away with their equipment, trying to do something, generating the knowledge and information. But in the end, each of us is equipped with one of these things. We're very lucky. It's an amazing piece of equipment, wonderful instrument. But it's what goes on in these things that will determine where we go in the future. I'd just like to point out to my space science engineering colleagues and indeed my computer science colleagues, this thing, it's difficult to draw an analogy between the way your brain works and the way a computer works. It's not quite equivalent. But it's estimated that this is effectively an exaflop computer. So as all of you, even when you're sleeping, your brain is executing a million floating point instructions per second, essentially, most of which are going on in the completely unconscious. And it uses about 20 watts, about a fifth of your body's energy usage. The equivalent top-ranking supercomputer in the world called Frontier, which is now an exaflop computer, so equivalent to this, weighs 290 tons and uses 20 megawatts of power to drive it. So I keep saying to my engineering friends, you know, nature is pretty smart. You've got a long way to go before you'll cope with this. Whoop, let's go backwards. So now I know I'm going a little bit over. I hope you forgive me, but I do want to do a little experiment. You've all been sitting listening to me, but I want you to do something for me. I want you to shout out a word 3 times, and I'll tell you the word in a minute. Will you do that? Yes. No. This is, you know, we were at a rock concert last night. That's not good enough. I want you to say yes. Will you do that? Yes. Good. Okay, now that's good. So the word is a very simple word, and I want you to shout it out 3 times quickly, okay? And so the word is cow. Cow, cow, cow. What do cows drink? Milk. Really? How many smart people do we have in this room? My agricultural friends tell me cows drink water, actually. Little cows drink milk from their mums and dad. That's not the point. So what happened there? Wait a minute. Well, in your head, there is software or wetware that's running all the time. And in a conversation, it's important that you respond quickly. You know, that you speak quickly. So, indeed, if people respond slowly, you know, if it takes 5 times for somebody to respond to you in a conversation, we kind of deprecate people like that. We say, well, a bit slow. we assume they're not very intelligent. So socially, evolution has taught us to respond quickly. And to make a mistake quickly is better than slowly making the right thing. If I'd said to you, cow, 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 what do cows drink? Think about it, and allowed you to activate your reasoning part of your brain, you'd have gone, oh, that word that my brain has brought to the top of the stack as the most likely word that I will need to utter next is the wrong word. And you'd have interceded, you'd have pushed milk to one side, and you would have said water. It's an illustration of the way that the brain constantly works in the moment, and for completely understandable reasons. So what would you say this is? I mean, it might be a polar bear, might be a dog. I mean, yeah, it's a bit difficult to tell. But actually, it's just knots on a piece of wood. But now you've seen it as a face, it's very difficult to unthink that it's a face. This is a very frightened-looking tree. This is a handbag, a pair of old trousers. This one's really interesting. This set the internet alight a while ago when the internet was not quite what it is today. But this is an image from an early Martian orbiting satellite. And there it is, evidence of aliens on Mars. They left this face looking at us. A few weeks later, when the image was taken with different lighting, it's obvious it wasn't a face. But once you've seen it, it's very difficult to unsee it as a face. And just for the meteorologists, I didn't want to leave you out. You even see faces in clouds. So the visual processing system in your head is one of the most powerful and important systems. And it has automatic recognition systems in it, and face recognition is really, really important from when you're a tiny child, you recognize your mother and father's face, all the way through life. Navigating the social world requires that you find faces. There's that thing about if you show people a picture with 100 people in it, you can instantly see President Kennedy or whoever your favorite pop star is. The visual processing system is hugely powerful, and you have no control over it. Once it's operated, you cannot unthink it. And I've worked with colleagues who I haven't got time to show, but there's some wonderful images where once you know that something in the image is one thing, that the processing system tells you something else. And what it's doing is it's delivering you information in context that allows you to navigate the physical world and the social world in the instant. Very, very powerful software. And so Daniel Kahneman, the Nobel Prize-winning economist, said, your brain is a machine for jumping to conclusions. And so there's the brain, that all of these different influences on the left-hand side, ranging from the evolutionary through to whether you just had a cup of coffee and the social influences. And so you stimulate the brain instantaneously. You make 30,000 decisions a day. So you're doing it all the time. Most of them are on automatic. Most of them are habitual. And so constantly, your brain is being stimulated to produce an emotional reaction, anger, fear, laughter, whatever. And those emotional feelings drive decisions and actions. And so the way this often goes is that something stimulates the brain. There's a big ka-chunk with all of these influences. These mental sensations get triggered, and you jump straight to the decision and action. So when I got you to say cow, 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 what do cows drink? A lot of you said milk. If I'd given you time to get your thoughts going, the reasoning part of your brain to intercede, you would have got the right answer. With the visual system, you cannot get over the fact that those aren't faces, but they look like faces. So what happens when you say to somebody, climate change? A little bit has gone missing there. If you say climate change, this is a hugely complex concept that triggers values, worldviews, experience, what other people have said, what you read in the paper this morning. And yet the same thing happens. The reaction is often without much reasoning and thought. All of us do this. We just react to something. I don't like the sound of that. So what emerges is really interesting. Daniel Kahan, an academic psychologist in the United States, says, tell me what the content of those question marks is, and I can use that as a probe of your brain. So if you tell me that climate change is a hoax, then I can tell you a lot about the value systems, your experiences, and so on that are stimulating your reaction to that. If you say it's a really serious problem, then it tells me you're a different sort of person and you have a different package of worldviews. So understanding that, what's going on in your audience's head, is really, really important. Because I've just told you a story. I've tried very hard not to generate fear, but I guarantee that all of you have been feeling a degree of anxiety, a degree of worry, a degree of loss, a degree of fear, and a degree of helplessness. And these are extremely unhelpful psychological stresses in your head, and your Mark I Paleolithic brain feels very uncomfortable with those, and it will be seeking automatic ways to reduce the level of stress. So it will either deny, it will just reject the information, or it will split, it will accept the information but not connect with it in your daily life, or it may connect and cause you to act, but only about 10 or 15% of people react that way. So as a physicist, I was never taught, or actually never taught how to lecture properly. You're supposed to, if you're smart enough to be here, you should be able to figure that out, was the attitude in my day. But we knew nothing about the way the mind works. We were never taught how to shape a story in a way that connects with the audience, engages them, but doesn't shut them down with fear and anxiety, but opens up the energy to generate hope and action. And so this is what's going on in your individual heads, but the same thing happens at the institutional level. So in an institution, there are real issues about how you respond to climate change, but many of them are psychological. You may have a boss who's decided that profit is more important than dealing with ethical and moral issues. Maybe they've got a legal, a fiducial duty to ignore these things and deliver profit to their shareholders. So how do you overcome these individual psychological barriers or these institutional barriers? Because we find that many people, many institutions that accept that climate change is real and want to do something about it are stuck because of things that are going on in their heads or the heads of people around them. So my neuroscience, so now I for the last 7 or 8 years, I've really stopped working on a daily basis with my climate science colleagues. I had several of them on a group that I run. But in the end, I decided I really don't need that. We know enough. I mean, of course, there's a huge amount more than that community has to keep doing, following what the planet is doing. I really don't need them because that is not where the problem lies, nor does the problem lie in the technology. Engineers and technologists are and can invent all sorts of things. The problem is in the head, in those 7.8 billion heads, and particularly in some of them that have real power. So my neuroscience colleague has scanned 50 years the body of knowledge in the social sciences, often very confusing, very contradictory, but he's a smart guy, and he's found 7 principles, which he calls laws of the way human psychology deals with the realities of the world around it. And these 7, he calls them laws. As a physicist, I'm not sure I call them laws, but they're very useful insights. We can talk about them afterwards if you like. I'm running out of time, so I won't take you through them in detail, except for the last one. And that is that as academics, as children of the Enlightenment, we are tutored and we tend to believe that we generate knowledge, we generate understanding, we convey that knowledge and understanding, and people will react. We think the world operates in a linear way. If you tell that to a psychologist or a neuroscientist, they'll fall about laughing and say, that is absolutely not the way human beings work at all. Because if you give people knowledge and understanding, all of those barriers come up to push it away if it's uncomfortable, if it doesn't fit with your worldview, or to accept bits of it but put them aside because they worry you. What actually drives action is action. If you do an action, the self-justification engine in your head says, I'm not a stupid person, what I did must have made sense, and the more clever you are, the better you are at coming up with reasons why what you did was good. That makes you feel good, and so you do something else. It puts you on a path of further action. It's only when you understand that you realize that the way that we've been telling the climate change story, this great epic narrative, as a problem is the wrong framing. The right framing is an activity. How do you get the agency to act? So the group that we've set up in UCL is called the UCL Climate Action Unit. It's a bunch of people who work with facilitating human understanding of how to overcome these barriers. We find communities of practice, communities of place who want to make progress but are stuck, and we work with them in a structured and tailored way. We set up workshops and processes which have a grid of activity down to the few minutes, and we carry these really smart people through a process, often to which they object. They say, I'm a smart person, I don't need this. So you have to persuade them that they do need it because we know that they do. We bring them into contact with people with whom they would not normally interact. We help them overcome the barriers of language and understanding, get inside each other's heads. And so our theory of change takes us around this process, and we end up creating agency and creating ways forward actions that nobody would have thought of beforehand. So it's a process that generates something which is unique, which people own, which they've developed themselves, and which makes real progress. It makes real traction. So we're creating the agency to act. And we work with Chatham House, which some of you will know is a kind of blue ribbon think tank in London, working with senior Chinese officials and British officials on joint climate change action. We did a program for decision makers, members of parliament, members of the House of Lords. We've worked with local government. We're working with institutions like the National Trust. We developed a handbook to help people who are going to COP26 in Glasgow communicate better their messages. And we've developed a program where we help decision makers follow policy pathways that give them the agency to act. So I'm sorry I've gone on a little bit long, but I hope you found it useful. We go back to this epic drama, and I said that we're all the actors in this drama, but we're all the script writers as well. And the future is not written. And all of you here, all of us, but particularly you here, you who are much younger than me, are important script writers. What gets written on these pages will depend on your agency and how you use that agency to change the world in the future. So you need to write those pages. And so what I'm asking is that you write the future, you do it now, but don't write it in red, write it in green, which is the color of hope. Okay? Thank you.
Thank you very much, Professor Rapley. Now we can take a few questions, and if you have questions, please come up to the microphones here, and Professor Rapley will address them, and soon after we will move into our youth challenging decision makers part. Any questions? People have to go to class, so they're not running away from you. Yes,
yes,
you have to walk up to the microphone.
So my name is Eva, I'm from Croatia, and I'm a psychology student, so this part of Kahneman and everything is quite familiar to me. And I'm here just a tourist, I'm visiting in Yerevan. I didn't have planned to attend Starmus at first, but when you're talking about all of these psychological things, I think in order to people can use their brains to reason with that smart things, there are some biological things in our brain that needs to be satisfied. Like, we need to have food, we need to have shelters. Like, if people have stress on their daily basis, like, you have a conflict right here, right now in Armenia. And you can try, I don't know, not to use public transportation or whatever, not to smoke, not to eat meat. There are some things that we can do, but if you come home and maybe somebody is dying, that doesn't account. It doesn't work. Yeah. It doesn't work that way because our primary needs are not satisfied. Yeah. So I think the point is we can take our responsibilities, but without, how can I say, global responsibility that is not here with us. It's like in the politicians, the decision makers that are bigger than all of us here. And I think if they don't do something, we can try our best, but I think it's not going to change anything.
Thank you, Eva. You've beautifully illustrated one of those barriers in our heads. That is that we live a daily life. If we're hungry, then we will get food because we need it, and we will disregard whether that action has a bad effect on the environment. And so that's exactly the point. When people say to me, oh, this is all very well, but what can I do? I was tempted in the past and often said, well, you've got your personal life, there are many things you can do, eat less meat, ride a bike, don't go on an airplane. You've got your professional life, if you're in a company or something, you can work to make that company more sustainable. And you've got your political life, you can vote for politicians who promise, and are sincere about doing something. But actually that doesn't really help people because you offer them this sort of smorgasbord of things to do, which is a bit confusing. And as they walk out of the lecture theatre, life takes over. They have to run to their next class. So you say your mum is ill in hospital. So that is why it's so important to understand that actions drive beliefs. So the way to deal with this is to say, given the realities of your lived experience, what is the one small thing that you really, really could do later today that would make a tiny difference, just one thing, which is, you know, practicable, reasonable, sensible, and just does something, you know, just even if it's a token to start with. And if you do that action, it will make you feel good, and I guarantee that that will then make you think, well, actually, I could probably do something else. And more importantly, your friends and your family will see what you're doing, and socially, we're very influenced by other people. And so if they see you doing something, they'll think, oh, well, maybe I can do that as well. I'll give you one example. I live on an estate where of 25 houses, where until recently we were not permitted to put solar panels on the roof for planning, very silly planning regulations. And one of my neighbors said, I'm going to fix this. And they spend a lot of time and effort overcoming the planning regulations, and they've now got solar panels on their roof. And they're laughing in the energy crisis. They're making money. They're not losing money. And so all of the other neighbors are now looking, and they're quietly talking to that individual and saying, oh, how much did it cost? How much money are you making? I guarantee that within a year, you'll see solar panels over all the houses. So the solution to your problem is to find that one little thing that you can do, and that gets you on the road. Does that help?
Of course, thank you.
Thank you.
Can I just say one more thing?
There's a lot of people waiting.
Okay,
Thank
yeah,
you very
okay.
much for the question. Next person, next student, please.
Well,
Try to ask a specific,
Yeah,
very
very specific,
question,
yeah.
because we have...
And I'll try and be much quicker in my
My
response.
question is about economics. You mentioned that to save our planet, we need to burn lots less fossil fuels, basically,
Yeah.
gas and
Coal and oil, yeah.
natural gas and stuff. So the whole world now, the whole world economy is working on fossil fuels, basically.
Yeah.
What can we do to make the governments in the
Yeah.
entire world change their opinion on using gas?
First point, I think you said save the planet. The planet is fine. I mean, it's been insulted by asteroid impacts and so on in the past. You know, the natural world will recover. It's damaged at present, but it will recover. And it's completely indifferent to what happens to us. So what we're worried about is what happens to us in society. But you're absolutely right. The truth of the matter is that to really deal with this problem in the long term, we have to do three things. We have to transform the way we power the modern world. We have to get off fossil fuels and onto other sources of power, because we need energy for prosperity. We have to change the way we finance the modern world. So, neoliberal market economy is proving to be not the way to operate, because the externalities are ignored. So somehow you have to get that system to recognize the externalities. And we have to change the way we govern the modern world. You don't have to point very far from here to see how humanity, ignoring all of these other things, can get into tribal warfare with each other. And so we have to overcome all of that as well. This is a huge, huge, huge task, and we don't have much time. So we can't solve all of those things immediately, but we can intervene in the economic system either with carbon taxes or with some other instrument that causes the actions of people who are making profit out of using fossil fuels think again and find another way of providing that energy and delivering it. And the clue there is that the most profitable and most powerful people and institutions on the planet are the oil, gas, and coal companies. And if they chose to really, really, really hit this problem and use their resources of human intellectual resource, infrastructure, and money to move quickly from a fossil fuel-based energy system to a non-fossil fuel-based energy system, that would be the shortest route between A and B. So trying to persuade them to be much more serious about their actions is really the answer.
Thanks.
Okay. Can you ask your questions and then maybe you can summarize and so ask your questions quickly, and our resident limnologist also has a question. Please move up to the microphone. Quickly
Hello,
ask your
Professor
question.
Rapley. I had two questions, but I'll ask the one that I feel is a bit more connected to our topic. You said that the levels of the carbon dioxide in the atmosphere have risen in the past few years. My question is that have we been able to find any solutions for that, whether it's on land or in the ocean, or any sort of solutions that we can extract CO2 from the atmosphere and either injected to higher levels or in the...
Yeah. The planet...
Wait, Chris, can we wait for everyone to ask questions,
yes,
and then
sorry,
you
we'll take
just
the
in
three.
one
Yeah, okay.
shot answer
Yeah.
the question. Please
Remind
move
me
up.
of it, okay.
Hello, thank you for this meeting. My name is Ophelia. My question relates to the brain thinking and real actions against climate change. Do you have any specific program designed like in collaboration with the psychological department and the climate change department in your university to work on young people's minds, like to relieve their stress, to come up to clear consciousness and to boost their like climate responsibility?
Thank you.
Okay. Yeah, and next, and then one more question, that's it. We're wrapping it up. Go ahead.
Hi, thank you so much for the discussion. I have been running a business for 2 years now. We're making solid shampoo bars to prevent the use of plastic bottled shampoos, so kind of an environmentally friendly product option. And as a person who sells this product, sometimes I have to also teach people why this product is better than the other, more environmentally, also usage related. But I'm interested like in the psychological aspects you talked about, like how you put down those barriers in people to get to them and get to their minds and say, okay, this is important. And connecting to the first question, like she said, so many people, especially in Armenia, are concerned about their food and shelter. So you can't just, tell people buy the soap that is more expensive than the shampoo. You have to kind of get them to that point where it gets to the environmental issues and climate change, how you put down those barriers.
I'll take the last one first. The marketing community for 30 years has learned how to persuade people that it's in their interest to buy a particular product. And often the emphasis has been, the big shiny car shows that you've been very successful, so it feeds rather base emotions. But by and large, people care. People care about the environment. They care about their children. And so you just have to find marketing messages that say, not only does my product fulfill your basic needs, if it's a soap or whatever it is, it makes you clean, it's just as good as any other, but in addition, it will help the planet, it will help you. There are marketing messages that you can weave in that appeal to people. And there's an example, there's a company called Lush in the UK that makes, them. And they have a product which is a cork product, which is to hold soap in, which is more expensive than the aluminium one that they used to make, but is absolutely sustainable. I won't go into the whole story. And their marketing people were worried that because it's more expensive, it would not sell well. But the sort of people who buy those products go, I don't mind paying 3 times as much for it because it makes me feel good. It makes me feel I'm doing that one little thing that makes the environment better. So that's where your messages come. Now, quickly, remind me of the other 2 questions. I'm sorry, I'm a bit tired.
So you covered the question of collaborating with psychologists, because that was a whole effort you have undergoing at UCL, Yeah,
the young people bit, yes, we're intervening in the science society domain, but of course, as university people, we're training young people in their courses to understand the psychology that they need in addition to their other things. And what's wonderful is that your generation is the social media generation. And whereas in the past, young people would have said, well, that's all very well, but I need to become a good ologist, a good engineer. What we find with young people these days is they go, well, this is fabulous. Of course we need to understand this. We need to make a difference to the world. And the first question was, remind me, sorry, the first of the 3. I'm really sorry. Yeah?
Reducing oil and gas to the power
yes, the planet. One of the things I didn't say, that we pump all of this carbon dioxide into the atmosphere inadvertently, we didn't do it on purpose, and the planet has been trying to help us. The ocean has been absorbing about 1/4 of that, the land biosphere has been absorbing about 1/4 of that, and only half of it is accumulating in the atmosphere. What worries us is that the ability of the ocean and the land to keep doing that is beginning to weaken as the world warms. Can we do it technologically? Well, of course, you hear a lot about growing lots of trees. They will trap carbon, but unfortunately, in a warming world, they tend to catch fire and release it again. And there's a huge amount of work going on trying to increase the rate of geological weathering by drawing carbon dioxide down into rock structures where the carbon dioxide binds as a compound with the rocks. But the cost of doing that on the scale that's necessary would be equivalent to the profit that is being made by the oil and gas companies in generating the problem in the first place. So this is why I'm skeptical about net zero, because everybody feels, oh, well, you know, in 20 years' time, we will be able to suck stuff out of the atmosphere at the rate that compensates for the residual going into it. I don't believe it. I just don't believe we will be able to meet that scale. So that's a real problem. I think we should stop.
Okay, thank you very much. So now we're going to switch gears, and I would like to just ask our students, participants to come up. Pali Bedurian will sit at the edge over there, and then next will be Narek Ohanyan. Where is Narek Ohanyan? And then Nane Khachikian, and Alexander Hakopian, Hrach Barseghian, and David Bagdasaryan. Yeah? So come up, sit that way, and maybe, Chris, you can sit in the middle.
Okay.
So, and then Irina Raplanian, please, will be one of our decision makers who will be challenged. So please next to Professor Rapley, and then Aslane Pasoyan and Aram Terzakarian. Irina is the environmental, senior environmental, no, next to Rapley. Is senior environmental expert of the World Bank covering the Caucasus. She just started September 1. So, and also she is a faculty member. She teaches at AUA. Aslane Pasoyan runs a very important nonprofit called Energy Savings Foundation, and she's been doing a lot of work on energy policy in the country since many, many years. And she also teaches at AUA and also the Agrarian University, ATC. And Aram Terzakarian is one of our experts at UNDP, United Nations Development Program, and he has spent most of his UNDP career on climate-related issues, adaptation, and so on and so forth. So we have the right set of experts with the right mix of students to really challenge. We're missing Narek. I don't know. I hope he's well. Okay. Okay, so let's start. The format, how it's going to work, each student has a perspective from which they're going to ask a question. And then you can either select who wants to respond, or if no one wants to respond, I'll ask someone to respond, okay? And Professor Rapley will be the voice of God, the voice of reason, he will kind of come in and intervene and say, this is how it's done elsewhere, and so on and so forth. So. Okay, so this is, we'll start with Pali Bedurian, who is representing the perspective of water diplomacy.
All right, so we are, can you hear me? Right. So we're all familiar with the impacts of climate change, namely on water systems and water security. My question is, do you believe climate change has impacted the geopolitics of water and water security in different countries? Naturally, this extends to our region in the South Caucasus as well. And in addition, what actions is Armenia taking to ensure that we have a strong and responsible position in this rapidly changing global political situation in relation to water security, of course?
Diplomacy, maybe Irina Raplanian, she's becoming the regional.
Thank you. It's good to see everyone, particularly our students who took the first pioneering class on climate change at AUA. And of course, such an honor to be here on the same panel with Professor Rapley. A very important question, and particularly very relevant to our region. And I'll bring a very concrete example because I think that will be showcasing the true extension, the true extent of how important water diplomacy is for this region and how climate change is affecting moving forward. So Armenia is actually fourth most vulnerable country to climate change in the Eastern European, South Caucasus, and Central Asian region. And part of that has to do with declining precipitation, declining river flow, and some of the projections are actually very, very scary and threatening. So Armenia needs to aggressively invest in construction of reservoirs, other important adaptation projects. And we have, unfortunately, very outdated infrastructure on reservoirs, over 80 of them existing in the country. Very few are functional, and most of them require massive renovation. Actually, World Bank currently is doing an assessment of 15 of these reservoirs. We have developed a methodology on prioritization of reservoirs and ensuring that there are substantial climate co-benefits in investing a lot of money into water reservoirs. And considering that a country has a significant component in its economic development, current and future, agriculture, which is heavily dependent on irrigation, the country really needs to invest. Now, what is important in geopolitics and actually geography of this region, Armenia, together with the entire South Caucasus, is a downstream country. An upstream country is Turkey, where we've seen aggressive, I wouldn't, stop using that word because this is something that has been qualified by other entities and stakeholders, aggressive construction of water systems and water infrastructures, particularly reservoirs, that have unfortunately impacted not only Armenia, but also Azerbaijan. It has impacted Georgia and further downstream countries like Iran, Iraq, and Syria that have suffered already from droughts that are caused by climate change, but exacerbated by this preying politics of certain countries on water infrastructure. And this is something that we need to address regionally, we need to address bilaterally. Armenia has 27 bilateral contracts, agreements with Turkey, which were struck during Soviet periods. So between Soviet Armenia and Turkey, we have all of these agreements, unfortunately, that have not been negotiated for 30 years. And this is something we need to start negotiating immediately because the planet is warming. Thank you.
Thank you. Chris, any global perspective on geopolitics of water?
Well, all I would say is that it's another example of climate change being a threat multiplier. Climate change isn't causing that problem on its own, but it's making a situation worse. So this interplay between climate change and all forms of geopolitics, you find examples of everywhere. It just makes things worse.
Thank you very much. Let's go to Nane Khachikyan, who represents the perspective of disaster resilience.
Okay, so as Dr. Kaplanian mentioned, Armenia is in the list of most vulnerable countries in the world, I can say, so to climate change. And if we look at the indices from World Bank's research, we can see that all the indices from 0 to 10 scale, 10 being the highest one, the most resilient score, Armenia falls under 5 in nearly every category. I would like to concentrate on 2 of them. The first being the propensity towards natural disasters, which is 4.3, and the next one being the lack of capability, lack of infrastructure to deal with the natural disasters, which is 4.8. So my question is, how does Armenia deal with it politically, with policies and actions to ensure that it is preventing and, in the case if the disasters happen, dealing with the disasters? And how can I, as a citizen of this country, feel that my safety is a priority for the government in those actions? My question is this.
Thank you. Let me ask Aram, because you've been working in the area of also adaptation and not necessarily only disaster management and resilience, but you're in that universe. If you could kind of, how seriously are the climate change impacts being taken, as Nana asked, in terms of preparing for wildfires, mud flows and flooding and landslides that are common threats in Armenia?
Thank you. And thank you for the question. Though the question is very specific, but the answer, we may have dozens of examples to answer. I would a bit reflect on climate extreme events and specifically how they affect the agriculture sector. And the government, you probably have heard about piloting agricultural insurance. I mean, they cover some sort of crops and some sort of climate extreme events in some regions, but this is a pilot project and they are working on it to expand the program. I mean, they cover, I think, hailstorms, now there frost, frost, and then working on the drought. And the project I'm working is currently, making an attempt to help the government to covering also the strong wind also. And this is a very specific example in regard to climate extreme events. Another point I would like to highlight, because I work from management standpoint, the government has developed a new piece of law on disaster risk management and disaster risk management. What is, why I'm highlighting this? Because lots of reference to climate change and climate change adaptation. And this is a very draft piece of law. It's not approved yet. It's not discussed in the government yet. I see it's just produced by the Ministry of Emergency Situations. And what I like specifically as a person working in the sector of climate change adaptation, the government agencies work in a very formal manner, yeah. And sometimes, email is not good, just a hard copy letter. And what I would like to highlight in this very specific case, someone, told us that there is very new specific piece of law, and I found the person in the Ministry of Emergencies. I contacted them. I said, we would like to help you if you need it, and we can go through the piece of law, draft law, and give you some recommendations how to connect it better to the management of disasters under the climate change conditions. And we developed some recommendations and just simply send it via email. Luckily, 95% of our recommendations are in the draft law. So this is, what I specifically like. They didn't go through normal, send us via your resident coordinator, whatever. But this is what government does currently.
So Aram, is that a good thing that they're informally activating? Your point was that there is positive movement, or that it's disorganized. I didn't quite get it.
No, it's. It was rather a positive example. Positive. I would like to say that just in some agencies you can go with emails, But I would like to say that to highlight specifically that sometimes informal manner of communicating with government decision makers might be more efficient rather than very formal one.
And we've seen across Europe what happened in Germany last year, and completely unprepared to deal with disasters like that, right? It's like one of the wealthiest countries in the world, and now you had this massive disaster, and people were at a loss, right? So we have to be super aggressive about how do we prepare for these disasters. Chris, do you want to add anything?
Yeah, there's a deeper issue here. Academics are naturally very reluctant to stray into advocacy, and in particular into activism, because we instinctively understand that can draw into question our impartiality and the extent to which we're being honest brokers of knowledge. And so the IPCC recognizes this by saying quite explicitly that its advice to decision makers is policy relevant but not policy prescriptive. So this is a barrier that academics are very nervous of straying across. And we all recognize that policymakers have many, many other factors that affect their decisions. So all that the science community can do is advise. If you do this policy, this will happen. If you do that policy, this will happen. And then the decision makers have to say, yeah, but we need to maintain, economic prosperity. We have international relations. So we have to recognize that we are just influencing decisions. But if you reach the situation that we're in now, with all of the issues that are being raised, some scientists, some very senior ones, have said, you know what, we are going, as human beings who care, we are going to have to stray into this area of advocacy and even activism. And there is something else that I've discovered, and that is that you can take off your academic robes, and you're a citizen, you're a person, you're allowed to have feelings and to express views and opinions. And so if you draw a distinction between your professional role and your role as a person, then you can express things that are more uncomfortable as an academic. The only thing I would say is that when you do that with a journalist and say, listen, I am speaking to you not as, Professor Chris Rapley of UCL or whatever, but as a person. Unfortunately, the headline always says Professor Chris Rapley of University College London said that the government is stupid, or something awful, and then I get the provost ringing me up saying, "What the hell are you up to?" So this is a very difficult area. In the end, personal relationships, develop personal relations, not necessarily with the politicians, but with their trusted advisors, so that they channel your information in a way that the politician can respond to.
Thank you. Alexander Hakopian presents the perspective of water pollution and water degradation, especially under the conditions of climate change. Yeah.
Thank you. So, continuing on the thread that Polly led us through regarding water, let's talk about the quality of the water that we do have, even though the infrastructure isn't as strong. So freshwater lakes and river basins all around the world, especially near cities and agricultural communities, suffer from unprecedented eutrophication processes, and we end up with water that contains a lot of algal blooms during the seasons, and also sometimes, in worst cases, cyanobacteria. And although that can be also led through, there are a lot of factors at play, including the global temperature rise. Some of the factors are not in our hands, including that one, but some are, which is the anthropogenic pressure and the anthropogenic pollution, as well as just agricultural runoff in the agricultural communities. So my question is, if we eliminate whatever is in our power to eliminate, is that enough, or are we past the point of no return?
And your question is about globally?
Globally, but a great example of that is also Lake Sevan in Armenia, having the same issues.
Okay. Astrine, do you want to take that on?
I'll try. Water is not my strength, but definitely there's several aspects to your question, though. It's not the anthropogenic pollution is increasing in terms of pressures, but the reason why that has become such a problem is that the absolute quantity of water in the basins is declined. The droughts, also the aggressive water overuse. Professor Haplanian already explained how much pressure we're under in terms of water use, but also the water consumption patterns in the industry, residential, municipal uses are so wasteful that one of those little things Professor Rapley mentioned could be changing the water consumption patterns. We know aquaculture is a one-way street in Armenia. It's a drain on underground water resources that is not only creating a pollution pressure, it's also creating a pressure for energy use, declining hydropower production, declining water availability for irrigation, and Ararat Valley being basically the heart of agricultural production, going from semi-desert to desert. With growing temperatures, what's going to happen anyway, but now with less water available, that will get aggravated. I have not seen the latest numbers, but the eutrophication of Lake Sevan is not only because the pollution has been increasing, but also because the base volume of the lake is not where it's supposed to be. And it could be higher, and the pressures are, again, politics. It is a political decision-making. We have, in our water course, we've talked about the need to balance the various sectors' interests. And they're trying to balance between agriculture, industry, and power, energy. And we're forgetting that there's a silent sector, the ecosystem, that needs its, basic survival level water quantity that could allow to digest, to deal with those pollutants, which have been going into the lake for decades, and the lake has been fine. Now the drop of the level and the increase of the pollutants is basically a concentration issue. I believe in terms of policies, there was a mention of how good our laws are, and I can speak about amazing laws. We have our water code is quite strong. We had at my start of my career, I worked on the Lake Sevan Action Plan, which spoke about the issues you're raising. And I was a student myself. I was younger than you are now, and nothing happened. We're not accomplishing anything. So that's why I love the title of the lecture, the agency to act, not to develop and adopt a law, because we have a lot of those, but to actually take action. And that's not happening. I believe if they take action, if pollution is controlled, if water use is more rational, there's, again, repeating Professor Rapley, the technology to save water, from trickle irrigation to circular aquaculture and a million more things that are still in state-of-the-art condition and we don't even know about them. The physics is there, the science has come up with all the solutions. And many of them are affordable, many of them are bankable, cost-effective, pay back within a reasonable time period. It's the desire to act by politicians and by businesses who need to take that action. I agree it's a psychological issue, it's a behavioral issue, and we need to dig deeper how to trigger that action, start that movement, turn it into fashion if need be. I don't know, whatever trend is required to motivate people to do more.
Okay, can I jump in there? You know, I highly encourage everyone to watch the video that Garabet Kazanchian prepared about the causes of eutrophication of Lake Sevan and what's happening to it. The climate change is exacerbating the situation, but the nitrogen and phosphorus that we put into is basically our untreated sewer water entering the lake. It is the agricultural runoff with subsidized fertilizers, artificial fertilizers that farmers use excessively, that gets runs off, and so there's a lot of policy problem, investment, that government, public investment, things that are missing and are not being done. And level of the lake, of course, will impact it, but these are some of very concrete things you need to say, I'm going to spend resources on this if I care about, the health of the lake. And whether we do or not, we need to, I haven't seen serious action to figure out how to do this. Yeah, and it's not rocket science. You need to build a sewer plant, treatment plant. Okay, so that kind of allow me before, Haraj, I get to you. Narek, who's not here, but he's one of our incoming first-year students here, has been, as he writes, an environmental activist since age 11. It's very cute. And we're getting this generation now in Armenia who are really, at a young age, have committed themselves to some of these issues. And he's from the Vedi, city of Vedi, and Ararat Plain, Ararat Valley is where he is. Lots of his environmental issues are kind of anchored in. And that's, as mentioned, that's one of the areas with highest risk of desertification in Armenia. It's a semi-arid, part of a semi-arid environment, which we are also, Yerevan is. And we have been using land so poorly over the past 60, 70 years that we see almost half of the land is salinized. And so, again, these are things we can do something about. What is the government doing about it? Irina, as a former Deputy Minister of Environment, we'll put you on the spot. Yeah.
Well, particularly, let me zoom out a little bit from land degradation issue and how lands have been mismanaged, and kind of also build on Sevan Lake issue. As you rightfully noted, I was myself a policymaker for 2.5 years, and particularly our team fought for more action on Lake Sevan. I mean, we're not inventing a wheel here. We actually studied extensively the case of Lake Constance, which is a lake between Switzerland, Germany, and Austria. The lake faced serious problems of eutrophication back in the 70s, and the three countries committed with a clear roadmap and action plan on how to recover the lake and bring it back to its normal, natural state. And they succeeded. It took them close to 40 years. It's a long road ahead. But it's an important one, and if you have a clear vision, clear strategy, and of course, all of that is clearly laid out in the roadmap, construction of wastewater treatment facilities and regulation of usage of fertilizers in those specific areas that have runoff into the lake, etc. So we presented this to the government. The issue is that in many developing countries, unfortunately, ministries of environment who are charged with a particular portfolio of climate and environment management are left alone. And very often you're faced with this lack of understanding across the government that environmental and sustainable development, environmental management and sustainable development of the country is not a feat of a single agency. It's a task that has to be streamlined into every government agency's action plan, legal documents, bylaws, etc. And much of what we try to do, is to ensure that there is this understanding. I mean, awareness is the first step, and then showcasing that it's not only in the functions of the Ministry of Environment to solve this problem. Particularly this and land degradation and many others are what is required from, let's say, Ministry of Territorial Administration to address, Ministry of Economy to address, etc. So right now, the government has this good idea of let's write these laws, including this year's, this iteration of government 5-year plan includes green economy strategy. Now that should be a complete remodeling, and coming back to the questions that were posed to Professor Rapley about how do we move forward. Well, we have to rewire the way we run our economies to begin with, whether it has to do with GHG emissions or the way we use other natural resources, including water and land. With salinization issue, and just to conclude this this aspect, the government of Armenia has taken upon itself a task to developing a new model by which the economy will be run. Now, it's a major undertaking, and hopefully, if and when the strategy is developed, it would be implemented. And we come back again to this issue. Once we have the strategy, how do we drive the government to actually move? And
if I could just jump in, because
sure.
we have 2 more questions and we want to make sure to get to them. My takeaway is that lots of talk, lots of text, very little moving forward. And we need to understand what is that political kind of
blockage, how can be unplugged, right?
Just to conclude on this point, okay. I think, again, coming back to this issue that, climate and environment agenda is not a single agency's problem. And that's an issue we face. We constantly try to raise the level of dialogue, and when we submit a new budget and say, okay, we need triple that.
Yeah, I think that's a lost cause if it stays in a single agency.
Yes.
I think the Prime Minister's office should have a climate task force and push it forward, right? So it has to go, but it's unfortunate that everything has to bubble up that way, otherwise nothing gets done.
Yes.
Right. Chris, yeah.
I'll make three quick points. The first is that Al Gore famously says, there's no silver bullet, but there is silver buckshot. And so all of the things that we're hearing about, if you can intervene to do one thing well and improve the future, you should do it, and you should do it for its own sake and for the fact that everything is interrelated. The second thing is that we're learning a lot about how rewilding, how capable the natural world is of recovering, provided it's not pushed beyond a threshold where it dies. So, if the Amazon rainforest goes beyond a certain threshold, it will turn into a savanna and we will have lost control. So if we allow nature, if we help nature recover, it will do so. And then the third thing is listening to this conversation, and please excuse me, I don't want to offend anybody who's been in politics, but we are very unusual people because we're people who respect the concepts of rational and reasoned thinking. But my experience and the experience of many colleagues is that in the political world, people who rise in the political world tend to think in terms of ideologies, and rather than welcome evidence that may contradict their beliefs, they reject it. And so this is, again, one of these in the human head problems. How do you get through to somebody who is convinced that their ideology is the right way to do things, that actually they're going to do something which is really damaging? So again, those personal trusted relationships are extremely important in overcoming that barrier.
Thank you. Those are very good insights. Last 2 questions are kind of interrelated. So if you could both ask the questions, and I think they can kind of answer, maybe everyone can jump in, because I think these are really big, big questions. So Hrac is representing transportation, and David is representing the perspective of, science, engineering, innovation, research, please.
So my question is on more of a simple side, and as we've seen for the past 10 years, about a decade, the production of electric cars has increased tremendously, and so I'm curious if the mass rollout of electric mobility is the right approach to dealing with climate change.
And then the next. Go ahead with the next question.
Thank you. The question I wanted to ask is really a fundamental one, so feel free to be creative about it. In the 18th to 19th century, it was an advent of the steam engine which ignited the flame of industrial revolution, which in its own right ignited climate change as we know it and experience today. And now it appears to be that engineering is the answer to the natural crisis it caused in the first place. Thus, at last year's COP26 in Glasgow, technologies such as solar geoengineering were heavily promoted. Those kind of technologies are really prioritized in the modern world. Of course, they're controversial. Of course, there is not enough evidence to support. However, it is truly a trend that engineering is kind of stepping in the way of climate action and the related issues. So my question is, can humanity engineer itself out of climate change? And if so, does it seem to be a viable solution in the long run, in the long perspective, in the next 100 years or so?
Thank you. So this is for everyone, okay? So we'll start. Astrid cannot hold herself, contain herself. Go ahead.
Please. Well, back to transport and e-mobility. I thought I taught you better than that. Oh, well, jokes aside, we talked about different sides of e-mobility and electronic vehicles and electric vehicles. And a lot of people in this country don't like my position on the topic because I try to advocate for the same message over and over again. Wait, stop, do your math, come back and make a decision. It is an emotional decision in very many cases because it's trendy, it's fashionable, it's a gadget. A lot of the politicians are going after ideology. Many of them are young men who just love cool cars. That's dangerous. Before they even think whether or not it's a good car, it just looks cool and it drives their emotions before their rationale. In case of Armenia, numbers show that greenhouse gas emissions from electric vehicles are lower than from those powered by natural gas, which are 72% of our cars operate on compressed or liquefied natural gas. LPG. So in terms of emissions, it's better. In terms of electricity, we're creating a demand for our power sector, which doesn't have enough infrastructure. For that market, if it grows, if we have more electric vehicles, our power sector is not ready. The infrastructure is not ready to supply enough electricity and doesn't have the right wires in the right places to charge those cars. So something needs to be done and act soon. But it's just, I'm talking Armenia. If we scale up, we talked again during our lectures about life cycle approach, and we need to also be very mindful of the whole production cycle of electric vehicles. Where do batteries come from? What happens in the mines? All the environmental pollution, up the stream from all those parts, especially the batteries, and what to do with those batteries when they become waste and that chemical pollution. But also on a net, there could be cases if we're basically buying an electric vehicle that was produced in a country that used coal in automobile industry, that irresponsible mining to produce the batteries, the lithium, the cobalt, whatever else they're putting in the batteries. These are other questions we need to answer. If we're just blindsided and we're looking at, this is a car and here's a tax benefit, let's promote electric vehicles because that seems to be like the good thing to do, we may end up in a direction we didn't plan for, and the consequences could be dreadful.
So the material footprint of the energy transition is not often talked about.
It's almost never talked about.
Right.
It's, again, because a sovereign state is making a decision what they want to do, they don't even focus on, okay, if I put e-mobility in my city transport, this is an issue every European country's city we're discussing with, their sustainable urban mobility, SOMP, sustainable urban mobility planning. They're like, we have a lot of cars that are using gasoline. Let's put electric buses And that way, the city will be clean from emissions from using petroleum, combustion of petroleum. Well, they're not going to think about, because it's a mayor, all he has is a circle he's in. He's not going to worry about where that electricity for his buses will come from, and that's the neighboring city power plant operating on coal, end of story. Okay, so, and that should give you the answer to the next question by David, because, you know, if we start shooting science in the foot, we may end up in the wrong direction as well. Engineers invented hydropower, which is an amazing technology. If the Ministry of Environment doesn't have the muscle to make sure that those hydropower plants don't disturb the ecosystem, make sure they have the environmental flow, the fish ladders, et cetera, are built in an environmentally sustainable and responsible manner, which can be done with hydropower, we're essentially compromising a beautiful technology because it's not properly done by the policymakers, by corrupt inspectors, by people who care about their business and profit so much they're ready to close their eyes and say, so big deal, my hydropower operates at 45% efficiency, but I don't have an operating cost. Let's waste the river. Okay? So engineers have nothing to do, vice versa. If engineers are asked the right questions, and somebody needs to explain what they're answering, because a lot of the policymakers don't understand what engineers are saying. So if they are the smart advisor behind the policymaker who has the right motivation, hopefully the right ideology as well, to put it to the right use, the only way we can get out of this is actually engineering. But that doesn't mean that's not the only way. It also, those little actions that every one of us can take when an engineer advises you, do this, you know, save water. Here's a water-saving shower head. Here's a, you know, not net zero, but low-carbon solution to your mainstream technology. A lot of the conversions, I believe, can happen on the places where energy use cannot be eliminated.
So can I jump in and ask each person, other than Astrine, our experts, to say one final word? Can we use technology to get ourselves out of climate crisis? Astrine's point was technology is necessary, but it's not sufficient. You need other elements in place. So please, Aram, if you want to say one last word on that.
Yeah, just a small remark on that electric transport. I mean, probably you have heard it also that the municipality of Yerevan is struggling with public transport, and you know, like there were even some miscommunication, misunderstanding between the government and the mayor, what kind of transportation. And my understanding, and probably you have heard that there was a tender and unsuccessful one. And my understanding was that the bank who was going to finance the municipality didn't accept the technical requirements because it was not, it was based on fossil fuel, I mean, gas, and they want. So this is, I mean, for me, if international banks, you know, like make this a mandatory requirement, a mandatory stuff, so this is something very important. From another hand, it's very complex issue. Exactly, and I remember the talks like 20, probably, if I'm not mistaken, correct me, but some 20 years ago, there was a talk about that photovoltaic panels and whether it's, you know, what we are going to do with when it's time to waste it, to take to landfill, yeah? But technology is important just to give us solutions. But the rest doesn't depend on technology and engineering only, definitely.
Thank you. Astrine, sorry, we've heard Astrine, Irina. So the point here was, you know, technology is not enough, but it's important. Finance and the whole global institutions that enable things to happen need to focus on pushing these technologies, financing these technologies.
I'll answer this question with an example from transportation. Yes, I'm of somewhat different view than Astrine on electric mobility, but one thing is absolutely clear, that before we upscale electric mobility in Armenia, we absolutely have to improve public transportation. There are multiple models done showing that if we improve public transportation, we can reduce our GHG emissions by up to 30%. And that is with better quality, more stops, better availability for passengers of the system. This is pertaining particularly to Yerevan. So with this example, I want to showcase that before we jump into technology and carbon capture technologies, we need to do our homework of greenhouse gas emissions. There are solutions there, from reforestation at scale to rewiring the way we run our economies, heavily dependent on fossil fuels. There are multiple models done that energy transition and energy revolution, if you will, is possible. The money's there, the political will and action is not. So to summarize, technology is needed, but solutions are there even without it moving forward. So with both being not mutually exclusive, I think we have to do our homework with existing solutions and of course, listen to scientists and engineers on how to move forward and look for innovative solutions.
Thank you. And the last word to Professor Rapley.
Thank you, yes. If I may, I'll just tell a little story. The Science Museum in London, if you ever have the chance to visit, is a wonderful place which showcases the story of the Industrial Revolution from the invention of the steam engine through to the present world. It's quite interesting that in the 1880s and 1890s, it wasn't at all clear that the internal combustion engine would become the dominant way of achieving mobility. Electric cars were actually quite dominant. And like all museums, the Science Museum's collection, 96% of it, 97% of it is not on display. It's held in an old disused airfield about 50 miles outside London. And there's been a long tradition that every year there has been a festival where all of the local population can come and see all of the old exhibits that they can't normally see because they're held in this reserve collection. And it's been a tradition that we bring out the electric cars and we have a race with these old electric cars, which only do about 10 miles an hour. But everybody loves to see these old electric cars. Well, a few years ago, one of the more inventive people who's involved in that festival decided to take a risk because he'd been talking to a company that's been producing electric motorbikes, very fast electric motorbikes. And he invited the local chapter of the Hells Angels to come. So there are all of the people there with their family and their children, and suddenly there's this roar, and this very fearful-looking group of Hells Angels arrive with their long hair and their Harley Davidsons. And they come and look at these plasticky-looking motorbikes, and they look at them with complete disdain. You know, goodness me, are you serious that we would ride these runways? And we see him doing about 100 miles an hour with the front wheel in the air. And he comes back going, my God, you've never seen anything like this. The acceleration is unbelievable. And so within half an hour, they were all racing up and down the runway. And then they came back and had a long discussion and said, these are brilliant. But can you add amplifiers that make a much louder noise? And can you make them smell of petrol, please? Because if you do that, we'll buy them. But it's a wonderful example of a social tipping point and how you get inside somebody's head and sell them a product that they really enjoy that makes the environment better. So I'll just leave you with that thought.
Thank you very much. So that's you know, I guess you gave us some concrete example of how you challenge an existing paradigm and to shifting their worldview. Thank you very much to our students who spent a lot of time preparing these questions and all of one day, I think, yeah. So very good. Yes, thank you, and also our experts, of course. You're all very busy people to take your time and come spend time with us and address our issues and concerns. And of course, Professor Rapley, again, we're thrilled you spend this time with us, and we hope to continue being in touch with you. Thank you.
Well done, you guys. Really good questions. Excellent. Very good. My pleasure.